Good morning, Aubrey. You're not the only one to have this problem with the ideal gas. So most of what is in here, you can skip over and look at this beginning or this final ending statement. It says begin by solving for T2. So what you have to know in order to get to that point is what the ideal gas, what the formula is. And it's P1, if I can get my pen to write here, P1 V1 over T1 equals P2 V2 over T2. And all this stands for is this is the original pressure, volume, and temp. And it is set as a proportion equal to the final pressure, volume, and temp. And that is all that is. The pressure and the volume are multiplied against each other, and the temp divides the two. And that's how the ratio is set up. So what we have to do to start with, knowing this, is we have to solve for T2. So that means we have to get it to where T2 equals something, right? So understanding and knowing how math works, we want to get rid of the denominator T2. We want to pull it out from being the denominator. So we're going to get rid of that by multiplying by T2 over here. And whatever we do to one side, we have to do to the other side. So this cancels. And we're left with T2 times P1 times V1 over T1. And this is P2 V2 over here, right? So now we want to get rid of the denominator over here. Same thing. We multiply everything by T1 on both sides. And then we're left with this cancels. T2 P1 V1 equals P2 V2 T1. All right, follow me so far? So now that everything is just multiplied against each other, they're all factors, we could pick and choose what we want to divide by. So because we know these three things are multiplied against each other, we could choose to divide by these two to leave T2 alone. So that's what we're going to do to solve for T2. So these two cancel. So that allows us to have solved for T2. It equals P2 V2 T1 over P1 V1. So this is where we want to get to when we want to start dropping in the actual value of these factors. It is so much faster to just arrange the variables and the parts of the formula and get them where you need them to be first than to drop the numbers in. The other way, you would have to drop your numbers in for everything, leaving T2 as the only variable, and then do all the math to get to here. And it would just be a much, much longer process. But if we do this first, where we get the variables to where we solve for T2 by itself, now we can drop these values in, multiply them, divide them, and be done. Okay? That's the whole point of what we're trying to do. We're trying to speed the process by not having to do all this early math. We just want to do the simple math. We want to reduce that time as much as possible by putting it into a format that requires the least amount of calculation. So this is where we are now. So now that we know that, now that we know what that is, we can just take it over here and start with that, right? So T2 equals, let me refresh my memory, P2 is on top, okay. So it's P2 V2 T1 over P1 V1. That's our formula. So now we start looking over here at the numbers. And we're going to look at P1, V1, and T1. Then the other two we could sub in is P2 and V2. So the initial pressure, volume, and temp is what it's telling us first. So the initial pressure is this. So that's 50 times 10 to the third equals the volume, because it's the second thing listed, it's going to be the second number listed. 0.008 times 10 to the negative 4. 0.008 times 10 to the negative 4. And the initial temperature is 300 times 10 to the 5th Kelvin. So 300 times 10 to the 5th Kelvin. The final temperature, this is the final part right here. Find the final temperature. That would be T2. A temperature, T for temperature, final temperature. If the pressure was this, so we write down the pressure, 0.00005 times 10 to the 14, and the final volume was this, 0.00014 times 10 to the negative 8. Now I'm here to tell you, if you put all these values in to the original initial equation, which is this, you will get the exact same answer as if you do it like this, because I have done it both ways. But it takes for stinking ever. This is faster. Reducing it here is so much faster. It's crazy. But in order to do this here, we've got to reduce these into standard scientific notation, because we don't want to have to deal with all these decimal places or these big numbers. We want to reduce it as much as possible. So I'm going to take a minute and I'm going to go in and I'm going to redo these. So this is 50. In standard notation, scientific notation, we don't want to have but one place, and that's the ones place. So we're going to move the decimal this way. Because it's moving to the left, it's going to be plus 1. All right, this decimal goes 1, 2, 3. Because it's moving to the right, it's minus 3. All right, this decimal goes to the left, 1, 2, so plus 2. To the left, or to the right, 1, 2, 3, 4, 5, minus 5. 1, 2, 3, 4, 5, minus 5. So now I can rewrite these and put them into the formula. All right, so T2 is equal to the pressure of 2, volume of 2, temperature of 1, right? Final pressure, final volume, initial temperature, initial pressure, initial volume. So the final pressure was this. We know we need to have the 5 times and 10, and 14 minus 5 is 9. Okay. Final volume is going to be 1.4, because that's where we move the decimal place, times 10. Negative 8 minus 5 is negative 13. And the original temperature is 3 times 10. 5 plus 2 is 7. All right, now we need the original pressure. That's 5 times 10, right? And 3 plus 1 is 4. And the original volume is going to be 8 times 10. And negative 4 minus 3 is going to be negative 7. Now we can do the math. Now that we have all of this in here, T2 is equal to, and all we have to do is multiply. I'm going to say calculate. Of course we're calculating it, but we're multiplying it. That's the operation of our calculation. So we say 5 times 1.4 times 3. That's 21. So 21, move this over here so we can actually see it the whole time. 21, now we bring times 10, that's our base. And now we just add the exponents. 9 minus 13 plus 7. Minus 13 plus 7. All right, that's 3 right here. We draw our line. We multiply 5 times 8 is 40. times 10, and 4 minus 7 is going to be negative 3. Okay? So much faster and simpler than if we did all of that other with numbers. Now we just have to divide these right here. Now we do the actual division. 21 divided by 40 is equal to 0.525. So 0.525 times 10, because this is like, we treat this like a variable. And whenever we flip a variable from the bottom to the top to combine these two, which is what we're going to do, the sign on the exponent becomes positive. So we're combining the exponents because they're the same variable. So that it becomes a 6. However, we have a decimal in front and we don't like that. We want to have a whole number, ones place, or we want to have a ones place in front. So we're going to move this decimal to the right. So that means we're going to subtract 1. So it's going to be 5.25 times 10 to the 5. And we can't forget to put that in our unit of measure, which, if we look over here, temperature is in kelvins, K. So this is the answer you want to type into the system. And the reason I switched from this X to the dot is because the dot, the multiplication dot, is what you have on your algebra keyboard. So you have to kind of remember that whenever you are typing it in, to switch over to this and not use the letter X, because the system won't read the X as multiplication. So if that's what you're doing, then yeah, don't use the X here. Use the little dot for multiplication right here on your algebra keyboard. So if you type this in, this is the right answer. You could also type in what this is whenever you multiply it, which is 525,000, K. Because if you multiply this times this, that's what you would get. All right, so that is how you would solve that. It's a lot easier when you read it all the way through and do this first. You know, just manipulate your formula to get things where they need to be so you could do the calculations a lot faster. All right, I hope you figured out what you were doing wrong or where you were taking a misstep. Probably somewhere in your calculation where you were putting it all together to start with. That's all I have for you, sweetheart. If you need anything else or you have any other questions, please let me know.